Alright, so last time I talked about limits of sums and limits of products, and now we'll be doing limits of compositions. So here we go. So here's our f of x is x squared, and here we have a graph of g of x. You want to find the limit of f of g of x as x approaches 1. Now, if you can plug the numbers in and it works out, it's okay. So let me show you. So we can just do is try doing f of g of 1. And if this number exists, then we're done. If it doesn't, then we're going to have to do something else. So let's try this. So g of 1 is about 2. And we'll do f of 2, which is 4. So since we didn't run into any problems, that's our answer. All right, down here, this looks a little bit trickier. We have, let's see, g of x is like a parabola, but with a hole in it. And f of x is definitely piecewise. So we're going to do f of g of x, and I can already tell that that's not going to work out because f of x is discontinuous here. So what you should do pretty much every time is break this up into two different problems. So this is going to look pretty funky at first, but bear with me. The limit of f of x as the limit of g of x. I'm sorry, wait. The limit of f of x as x approaches the limit of g of x as x approaches 0. That looks really weird, so let me show you what that means. So first we'll evaluate the limit of g of x as x approaches 0. And so let's try plugging in x approaches 0. So x approaches 0. Alright, so that's -1, because like see how g of x is flattening out right around -1, and there's a hole there. So that is equal to -1. Okay. So now what we'll do is we'll do the limit of f of x as x approaches -1. And that is going to be, we got a problem here, because see, f of x is discontinuous at -1, so we're going to have to break this up into one-sided limits. So let's look at the left side first. So x is less than 1, or -1. We're going to use this top one, plug in -1, and we get 2. So this is equal to 2. And then we do the same thing with the other one-sided limit. X approaches -1 from the right. So we're going to use this bottom function here. So -1, 2 to the power of -1 is 1/2. So since these don't match each other, then this limit doesn't exist. So we're done. The limit, oh well, I don't need to rewrite it. We are done, so this limit does not exist. And I'll just write not equal right there. Okay. Down here we got another one. All right, this one's discontinuous in both places. All right, so what we're going to do is we're going to do limit of as x approaches 2 of f of g of x. So first off, I'm going to try and find the limit of g of x as x approaches 2. And, oh, it's discontinuous, so I'm going to check each side individually. So limit of g of x as x approaches 2 from the left is going to be this part. We're going to plug in 2 and we get negative 2. And then we're going to do, let's just use a different color, the limit of g of x as x approaches 2, and then we're going to check the right this time. So we're going to do from the right, it's going to be this bottom piece, plug in 2, we get 2 times 2 is 4, 4 minus 3 is 1. Did I do that right? Yeah, I did that right. Okay, now these two are not equal. So technically, the limit as x approaches 2 of g of x doesn't exist, but that might be okay. So what we're going to do is we're going to branch this off into 2 different problems. Because remember, this is negative 2 and 1 aren't our final answers. That's just what you plug into f. So what we're going to do next on the top part is we're going to do the limit of f of x as x approaches negative 2. Oh, I should clarify. Okay, so when we say limit of g of x as x approaches 2 from the left, I'm going to plug in something a little bit smaller than 2 because that's what from the left means. So something a little bit less than 2, negative, or 1.999. And we apply g of x, we just get negative 1.999, which is a little bit greater than negative 2. So what I'm going to do is say that the limit of g of x approaches negative 2 from the right. So that way when we plug it in over here, we can use that. Alright, so now how we evaluate this is x is approaching negative 2, that's this area right here, from the right, so over here. So that means f of x is approaching 0. Okay, we're good. And then down here, limit of f of x as x approaches 1. And that's going to be, or let's clarify, if you plug in 2 from the right into this function, you get, so let's say 2.01 times 2 is like 4.01, and then minus 3 is 1.01, so a little bit greater than 1. So from the right. So if we do that, we go to the 1, and it's just 0 again. So now, as you can see, let's use a different color for that. These two numbers are the same. And then remember, this limit right here is what we were trying to solve, not this one. That was just a step in the process. This is our answer. So that's our answer. So this is 0. It doesn't matter if g of x is discontinuous, or even if f is discontinuous. As long as those one-sided limits are the same, you're good. All right, what's next? All right, f of x, it's got 2 discontinuities. G of x has got 1. So we're going to do the same thing we just did. We're going to say, we're going to look at the one-sided limits one at a time. So limit of g of x as x approaches negative 1 from the left. And we have our other color, limit g of x as x approaches -1 from the right. And this Korean one, we're going to do -1 is a little bit, or x is a little bit greater than -1. So negative 0.9. And we're going to use this side because it's greater than -1. So negative 0.9, we're going to plug that in. So we get 0.9 plus 1, which is 1.9, which is about 2 from the left, right? Because 1.9 is a little bit less than 2. And then over here, so similarly, we're going to pick a number a little bit less than -1, so negative 1.01, negative 1.1, whatever. So we're going to use this function, multiply it by 2, we get about -2. And it's going to be a little bit less than -2. All right, these two aren't equal, so but that's fine, because remember, we're not done yet. So now we're going to do, for this top part, we're going to plug in this value right here, this limit, into our f of x function. So x approaches -2 from the left. So let's look at our f of x. We're going to approach -2. That's over here. From the left, so from this side, and we're going to, and 1. 1, yep, okay. And then right over here, plug in this value for our limit. So we'll do the limit of f of x as x approaches 2 from the left. So we're going to go to x equals 2, and we're going to go from the left. So we're going to go wee, and we end up at 1. So that equals 1. Oh, and look at that, these are equal again. So that means our limit does exist, and it equals that number, which is 1. Well, I don't know why I wrote it that like that. All right, there you go. That's how you do a limit of a composition. You just do sort of like a composition of the limits, and just focus on the one-sided limits.